Hi, thank you all for being here today. So I'm going to talk a little bit about a package that I've been working on for a while now for parsing both Quarto and R Markdown documents in R. I'll give you a little bit of context of the package, why it exists, and what we're trying to do with it. And then at the end, a little bit of a sneak preview that we move out of the realm of sort of the boring infrastructure tooling to what hopefully might be a little bit more exciting that we can do with this kind of thing in the long run. So the package is called parsermd. There was a lively debate in my house about whether it's parsermd or parsermd. This started before Quarto existed, so it was only about R Markdown documents. I lost that argument. It's now parsermd, so we can support both of them, and I don't have to rename the package and change all the functions. But it's a package that supports both of them equally because fundamentally, behind the scenes, they're the same structure, the same grammar, that kind of thing. This is one of these COVID projects that started. It's been off again, on again for about 4 years now, more off than on most of that time. But it's something that I've come back to sort of last year and this year a little bit more. And it's in a much better place now. And I feel pretty good about all of this. There's older versions that are on CRAN. There's like a maintenance version a little over a year and a half ago. The new version 0.2 should be up imminently, although I did say that last summer as well. Life gets busy when the school year starts, but we are in a place where I think that we can do that and we can support all of the Quarto features we want to. We'll go into some of the more details behind the scenes. We're using S7, we're doing some other stuff I think that's kind of interesting, but for your day-to-day usage of the package, that doesn't matter very much. But there's some nice features in all of that. And all of the examples today will be Quarto, doesn't matter, plug it with an R Markdown document, it'll work fine. There's a parse QMD, there's a parse RMD function. They use exactly the same backend. They only exist for aesthetic reasons, not for any practical technical reasons. So I'll go into a little bit of details about how the package works, some basic functionality, and then we'll see where we get to from there. So to start from, I've just basically taken the example Quarto document. If you go to quarto.org, the example that you're given there, and the point is that Quarto documents have a regular structure. That's why we love them. That's why we use them. But just to point out a couple key elements so we're on the same page with terminology. So we've got things like the front matter. So those little triple dashes, YAML format, and then within that sort of lists-based structures. We have HTML headings. So the number of hashtags indicate the heading level, and then there's some label that's associated with that. Within the headings, we then have other things. So we might have R chunks. So in this case, this is code that Quarto will run in the background through the R engine, and then we will get the rendered output in our outcome. Those chunks have designators. For older R Markdown documents, the options might go in those curly braces, and then in the more sort of modern hash pipe kind of format, the options are now YAML that goes. In this case, both of those options are available. You can use both of them at the same time. You can use one, but they're sort of exchangeable. That's complicated to support. And then you also have the actual code for whatever engine you're looking at. So all of this is dealing with R code, but parsermd doesn't care about the language. Again, it's treating the Quarto document as a text document. So Quarto is what's actually running it, what's using Python or R or anything else. So we're agnostic to that. We're just a way of interacting with the actual document. A couple other things that we want to support. So Quarto-specific features that are important to know about, things like fenced divs. So this is a pandoc kind of thing, but Quarto uses it heavily. So being able to know that those exist and interact with them programmatically was important. So that's a feature that we've added in the recent version of the package. So being able to figure out where the fenced divs are, where they start and where they stop, the class associations that you can associate with those, that kind of stuff. And then you can also have sort of standard markdown things. So this is not a code chunk, this is a code block. So this is code that we want to render in style, but it's not code we're actually going to run. Those are different, we want to pay attention to them, but there's useful metadata in this that we want to take advantage of, so knowing what language is being used. So this is a Python R code block, not an R code block. So knowing that is a useful thing, and that's something we want to expose to our users when we parse these documents. And then the other thing that's been alluded to in just the previous talk, there's also shortcodes and other kinds of things that Quarto does to add extra functionality, to access extensions and that kind of thing. So we also have the ability to detect those. Those are tricky because they're inside of other things. So you can have a shortcode in your YAML, you can have a shortcode in your code chunk, you can have a shortcode in your Markdown. So we have ways of dealing with that. I'm not going to get into it too much, but you can look at the documentation and see how that works. But we have the ability to detect them, interact with them, and do things in the context of one of these documents. So what does the package do when we feed this particular Quarto document into it? So we have a simple starter function, parse_QMD, parse_RMD, pick your poison, they're equal. You point it at the document, it will then read it in and it will parse it. So the parser is implemented in C++ using a library called Boost Spirit X3. You don't need to worry about any of those details, but we have support for all of these various language aspects and syntax of Quarto documents. And what we're going to do from that is we're going to build you an AST, and thankfully I'm not the first person having to mention this in this talk. We've already heard about them. ASTs are abstract syntax trees. It's just a way of representing the programmatic structure of this document. And in our case, the dirty little secret is it's not a tree, it's an abstract syntax list. Because Quarto documents are really nice and they're quite linear, so we just read them in block by block, and that's what we store. And so when I'm printing this out, what we can see at the top is the YAML. That was followed by some markdown text. Then we had our R code chunk. So we can see that's R. It's a chunk. It's R. It has 4 lines. And then we also expose the label, if that's there, because that's useful for sort of signposting where things are. Then there's headings. There's markdown, chunks, fence divs. All of those things that I just mentioned on the previous slide are represented in this AST. But note here, when I'm printing this out, I'm passing in this extra argument of flat equal to true. So this is the explicit how we actually store things. But what we show it to you, we show it actually in the form of a tree, because we think that's useful for a way of thinking about how the document is structured. And in particular in Quarto, the way we structure our documents is by using headings. We organize things based on the level of the headings to say these things are related to each other in a section. And we want to expose that to the user because that's a useful way, again, of signposting, of saying this content is related to each other. They're all under a common heading, and we want to expose that to the user. So what we have here is sort of an implicit tree structure that doesn't really exist, but we show to the user to show you that, okay, this markdown thing under Meet Quarto is under the Meet Quarto heading. And then under the other Quarto features, we have a heading, fence div, a code block, so on and so forth. And the real reason for this is so that we can give the user a better way of navigating that document dynamically and programmatically. So why hierarchical? Because we're going to cheat. We're going to leverage the tools that sort of exist, or at least be inspired by the tools that exist in HTML and CSS, to use a CSS selector-like approach for letting you pick out what parts of that AST do you want. Because again, we don't want you to be navigating that programmatically by using magic numbers and say, I want the 3rd node or the 5th node or anything else like that. We want it to be in the context of the actual document. So the example here is we have this RMD select function, and the primary way you're going to use it to navigate things is with a set of helpers. So the most common one is going to be by section, which lets you specify, I want this particular section of the document based on a particular set of headings, again, using their name as a way of specifying that's what you want. So in this case, if I want just the Meet Quarto section, I can specify that, and I get a subsetted version of that original AST. I can specify I want the fenced div section, that gets me that, and note I get both the heading and then all of its implied children from that hierarchy that I was showing you on the first slide. We can get fancier, so we can use wildcards. So again, we default and allow for sort of globbing for wildcard matching. So in this case, saying find the other Quarto features section, or the heading, and within that there then needs to be another child heading that has codes somewhere in it, and that's what we're going to grab, and that's what we're going to pull out. And note here, we maintain that hierarchy when we pull it out, so we get both the other Quarto heading and then the ones below it, but none of the sort of the sibling things that were there that weren't specified in the selector. If you don't want the parents, you can turn that off. Note we've also been dragging that YAML node along. The point of the reason for that is generally we want this to be a valid Quarto document, and the formatting is in the YAML. So we'll generally give that to you for free most of the time, but if you don't want it, you can turn that off, and now I just get just the headings and just their subsetted parts. So that's the main reason for this hierarchical view. Keeping it as a list, keeping it flat makes it really easy to work with programmatically, but then giving you a more interactive, more human-friendly version of being able to pull things out is sort of our design goal in all of this. Great, so I can subset a Quarto document. What can I do once I do that? Well, often I want to get pieces out, remove them, and then I want to turn it back into a Quarto document. So any of these ASTs or any of the nodes, I can then feed back into our asDocument function, and it will turn it back into a textual representation of that Quarto. And so again, the point of this is we can round trip. So we check extensively in all of our tests, take a Quarto document, parse it out, and then turn it back into a document. If they're the same, great, we're doing a good job. If it's not, something's gone wrong. And so again, just letting us turn these things back and forth between these various formats lets us play with these things, generate subsetted documents without having to manually edit them at any point. There's also a bunch of other selectors that we provide to the user, again, through this RMD select function. This is both directly inspired by and uses extensively the tidy select syntax from the tidyverse. It's super powerful, it's super great. And so we have a bunch of other helper functions that let you select nodes based on their characteristics. So we've seen the bisection, but then we also have things like has label. So checking for a chunk that has a particular label or a particular label pattern is useful. Has options, so I want to select all of the chunks that are not being evaluated currently. So eval equal to false, so on and so forth, and they let you pull these things together. So again, just various examples here of ways of selecting for all of the chunks that have a P in the label somewhere. Checking for has heading meet Quarto. Again, because we're using tidy select, I get a lot of things for free like the logical not or a range selector, so I can select between two headings. I can select other things. So the one difference from like how the select in dplyr works versus what we have, select in dplyr, the different arguments you pass are logically anded together. Ours are logically ORed together because we want to be more permissive in terms of getting multiple different sets of nodes in different ways, and that makes the most sense for our use case. So this has type RMD YAML or chunk pulls it in one way, or I could pass that in as two separate calls to the has type. So it lets me pick out a particular node type to subset. And again, as I mentioned, we get all of these other nice functionalities from tidy select. So not works with all of our helper functions for free automatically. So we can select, I want to get rid of all of the markdown text in my document. It's one line of code with RMD select to just purge that easily. Other kinds of things. Again, making it into the text is great, but often I want to then turn it into an actual rendered document. Great, we just support that. So again, it's just wrapper functions that support the Quarto render call. So you can pass your AST directly to that, and we can take your document and then turn it back into the rendered thing. So here's the rendered hello Quarto. And then maybe I want a version of this that is just the code. So just stick in the RMD select. I can pull out just the chunk types, send that through render, and now I have, again, just the version of this that just has the code. But maybe I'm not super happy with this because, note, like the generating the plot here doesn't have the code. So I grade a lot of student work. I want to see their code to know how they do that. So maybe I don't need their write-up or their other descriptions, but I need this other thing. So what I now need to be able to do is both select for this AST, but then also modify that AST in place to get different options, different changes. So another functionality we've added just recently is this RMD modify function. The difficulty here is your AST is heterogeneous. You have different nodes that are throughout. So we need to be able to apply things to only certain nodes at certain times. And so the way that this works is this is sort of like a map if you're familiar with that in Per. So what I'm going to do is I'm going to iterate over all the nodes, but I'm going to give you a predicate function that will determine which node I should look at, which is basically just one of the select functions we just saw. And then I'm going to give a function that will then do the actual modifications here. So in this particular case, I'm going to start with the original document on the left here. The RMD modify is basically the first function argument is the modification. So in this case, what I'm going to do is use the RMD node set options to basically just set echo is equal to true, message is equal to false for any function, any chunk that that's applied to. And then I'm going to apply that just to the has type RMD chunk, because trying to do that to a markdown node doesn't make any sense. And rather than throwing an error or just ignoring it, we can subset it and do it specifically as you go through. So what I get here is just the version of that document that is just the code. So note here, we're setting echo equal to true, message equal to false. In this case, we are defaulting to the YAML style options. That is something you can control with an argument to the as document function. So if you want the old style R Markdown options, you're totally welcome to them. And we rectify and resolve those between the two. So even if your document has multiple versions of them, they all go into the same place and are resolved nicely for conflicts. So that's the basics. There's some other functionality there we won't touch on now, but I want to at least give you a couple examples of like, why do we care about this? What are we trying to do with all of it? So I'm going to call this one file to rule them all. I'll give you a use case from my own personal workflow and try to justify why we care about this and give you some ideas of how you might use this as an infrastructure tool. So I teach statistical computing here at Duke. We make heavy use of GitHub to do that. So every single assignment is a Git repository that we distribute to the students. They do their work there, they push, we then clone it and pull it back. So that's how we send things out and collect everything. As I'm working on this, I need to set up those repositories. And so what I inevitably end up doing is I set up the initial repository for the students called homework1 that has a homework1.qmd that's sort of scaffolded for them. I give them the headings of where I want them to put stuff, and I leave some blank spaces like put your code here, put your write up there. I then need to generate a sort of mirror or a parallel repository that is the key that has the solutions that I can then hand off to the TAs for grading purposes. This is what I've done, and I've done it for years, and it works. It's fine, but it's a clunky solution because I now have two repositories that need to be in sync with one another, but they have a tendency to diverge over time. So if I change one of the questions in the student version, I have to remember to make that change in the homework1 repository at exactly the same time. And again, inevitably, entropy takes over, and these things diverge. And I lose the thread a little bit, and they get out of whack, and my TAs complain like, question 2 is not that anymore. Why? Oh, sorry, I forgot. Let me go back and fix it. So why can't they be one repository? Well, because if I try to mix the answers and the scaffolding in the same place, they step on each other. I can't knit it. I can't run it. It gets messy really, really quickly. So what I would suggest is when you have a tool like this, you can now have sort of one repository that is the ground truth from which you can then derive and generate the homework1 and the homework1 key for your different audiences in a convenient way. This is not a new idea. Kelly's done work on this in the past with other packages. People who do stuff with multilingual things have similar problems of like maintaining a Python version and an R version. And it's complicated and it's messy. This is not a universal solution, but hopefully it suggests some ideas of what you might be able to do. So what does this look like? Here's my homework1.qmd. Again, the point is not what's there. More just sort of about how we structure the AST, because we do need to be a little bit careful about that to make this sort of as compatible with parsermd, or to at least make our lives as simple as possible. But note what we're doing is we're using headings to structure things. So each question gets its own heading. And within that, I'm then being very careful to label my chunks with a suffix that indicates what it is. Is it a key or is it for the students? Because that's going to make it very easy for me to select those nodes out or keep them or remove them as I go. So that's the key thing to take from this. One heading per question and suffixes to identify what we have. And so then to generate the two versions of this, it's just a little bit of code putting this together. So for the student version, I just need to go through and select for anything that has not the label dash key, straightforward. And then to like hide the sausage making from the students a little bit, I don't want them to know that I have a chunk that's just called students for them. I can also then use that RMD modify function to get rid of that student suffix on the actual chunk. So I just delete that label and then give them out. So now you can look on the left-hand side. I've got my YAML, I've got my heading, I've got my markdown, and then I've got the named chunks as we go. And note, I get setting automatically because that didn't have a suffix, so it comes along for free. The TA version, basically what I want to do is I have to be a little bit more careful because I want both things that have the key suffix, but I also need to make sure that I get the setup. But if I just used has labels, I wouldn't get the headings. So that's why that has headings is there, and that's why we OR these things together to be able to come up with a reasonably consistent selector. Note here in this case, I'm also then removing all the markdown. Because again, for my TAs, they often don't want the markdown, they just want the solution, they just want the code that they're comparing with. So I can get a much more simple, more minimalist version of the document easily to them. And on the right-hand side now, again, we still have all the chunks, all the headings to keep track of where things are, and they're labeled appropriately, but we've dropped the things that we don't need. And so the point of this is this generates these documents. It doesn't tell you how to make the repositories to move them out, but that's the kind of thing you can write a function that you can have your sort of ground truth core repository, which then automation runs to then build the other things. So targets a makefile or something else can take care of that for you and hopefully should work reasonably well. I will say I have not done this for myself in the past. I've done the old way of doing things. This year, I am trying to eat my own dog food. This is what I'm going to be trying to do. We'll see how it all works. I'll be documenting these kinds of workflows. I'll be putting up my automation, so I'm happy to share those. If you all have things where you try this and it works or it doesn't, let me know. I'd be happy to share those as we go. So what's next with all of this? Again, weak promises. I'm not reliable on this kind of thing, but we really do intend to get this current version up on CRAN soon. It's at a very stable place. There's a couple things we want to add, and other things, a lot has changed. So there's not a ton of packages that depend on this, but we're going to definitely break stuff, so we need to wait for those rev deps, the reverse dependencies to get fixed, sorted out, just to make sure that we're not ruining anybody's life. And again, the other bigger picture things that we're interested in is building out and documenting interesting use cases. So this homework example is one of the vignettes that I put up. If you have other use cases, reach out. I'd be more than happy to publish those and say, at its core, the function of the package is not sexy, it's infrastructure. What's sexy is what you can do with it, hopefully. And so I'd love to know more cases about that, love to be able to show those kinds of things. One of the other things with all of this is, like, I've definitely felt it myself. As soon as I try to use this in a practical way, you start noticing the rough edges and the ergonomics and where it's problematic. So in those cases, when that happens, let me know. I'm very much focused on my own workflow. If your workflow isn't compatible with this, I'd love to know about that, where I can improve things, where we can fix things. And that will come from usage. So the more people do that, the better it'll get. So that's also something I'm very interested in hearing about and being able to improve, add helper functions, add that other kinds of stuff. The core, I think, is very solid at this point. So what else we can do in that space? So where I want to end up now is, okay, great. So this is all this. And again, what I'm going to show you now didn't exist when I put the abstract in for this. So I'm also on the train of, let's try some vibe coding. Let's see what we can get out with. This is why I wrote this package in the first place, was to build this app. So this is a companion app that's built on top of parsermd, called markermd. Because the goal was to grade a large class using this repo-based workflow. So there's some screenshots here in the actual slides. You can pull those up. But what I'm going to do is brave a live demo. So this is up on GitHub. Idea being, okay, I have a key. I want to build a template from that saying this is how the document's supposed to be formatted. I can dynamically work through the AST. This is the exact same thing we showed before, but now I can associate those nodes with a particular question. So question 1 is this particular heading. I can also put in validation rules. So logical checks to say that, okay, this heading should have a chunk that's called this, so on and so forth. So I can build out a template. Once I do that, I can use that template to populate the actual marking interface. So those in this space may recognize it's directly inspired by another software product out there that does not work for me and I cannot stand. But the idea is really good if your workflow matches to theirs. So what we have here is a collection of repositories of student work. From that, it's pulling in from GitHub and other places to get information. We're also pulling in artifacts from GitHub of the rendered documents. And what I can do is, again, validate to make sure that their document conforms to the expected structure that I have. That's using that template I just showed you. But then what we have is a grading structure. So what I have here is student work. This is the rendered document. I can also flip back and see the raw RMD or QMD document. I can flip around between the different questions. We highlight what's there. We also have a rubric where we can add items, point values, adding and subtracting, positive and negative things, and then we get a point total for each of these. So different questions. As we navigate around these things, we're taken around to these various places in the document. This is very early days. This is very heavily vibe coded. It's been an interesting experience to try all of that. It seems to work so far. I would not use it for anything in production yet, but I will be trying it myself this semester to see what I could do with it. If you want to try it, it's out there. It's on GitHub now. Do so with caution. Don't do it in a way where you'd be very sad if your grades just magically disappeared or the grade calculations were wrong. There's a lot of sanity checking that still needs to happen, but that's going to be happening over the next semester or so. So it's something I very much would encourage people to take a look at, try, play with. It is also very much conformed to my particular workflow. So telling me where I can't make this work, I can't figure this stuff out, that would also be very useful. Or can you extend it to this other thing? So I just want to put that on people's radar that it's out there. And just put up the final slide. All of it's up on GitHub, parsermd and markermd. Take a look, play with it. Let us know what you find. Thank you.
Great. Can we have a round of applause? Thanks.